Recursion is when a program calls itself. We can use recursion to simplify the coding in some difficult algorithms, but we generally pay a price in increased execution time. The basic idea with recursion is you take a complex process and reduce its complexity by a factor of 1 every time it calls itself. Eventually the order of complexity reaches 1 or 0, called the simple case, and we're able to solve that by inspection. So this is the general form. This is the simple case, solve it, else redefine the problem by using recursion. So again, every time you do this, it reduces the complexity by 1. When you get down to the simple case, you go ahead and solve it. Then it gets a little more complicated. As you go back through the process here, it returns from this call, and then it ends up back in the same program again. So it returns again from that call, ends up back in the same program. And you kind of work your way backward until you've returned from every single time that you've called this program, and finally you get the right answer. So let's take a look at an example to see if we can figure out a little better how this works. Okay, so consider the problem where we want to multiply, let's say 6 times 3. Although this is an easy problem to solve without recursion, I'm going to use it to illustrate the process of using recursion. We'll assume for the moment that we can add, but we don't know how to multiply other than by 1. If we multiply anything by 1, we get the same answer, so that works fairly easily. This is a third order problem then. We can reduce it to a second order problem by realizing that the solution can be rewritten as 6 times 2 plus 6. Okay, and then 6 times 2 can be rewritten as 6 times 1 plus 6. Finally, we get down to the case where we have 6 times 1, which is the simple case, and we know there that the answer is just 6. So I'll show you how to do this in general using this multiply function with two integers, m and n, where we're going to say that m is 6 and n is 3. So we come into this the first time, n is not equal to 1, it's equal to 3. So we come down here and we say the answer is equal to m, which is 6, plus multiply 6 times 2. So now we're calling this program again. This time we come in with m equal to 6 and n equal to 2. N is still not equal to 1. So we say the answer is m, which is 6, plus multiply of 6 times 1. Now we come into this with this equal to 6 and this equal to 1, and we go if n equals 1, answer is equal to m. So in this case, the answer is equal to 6. We skip the else and return that answer of 6. So that's an answer that is returned from this function one time. But remember that we called it 3 times in a row. So the next time it's going to return here, and it's going to say m plus, and then for multiply m times n minus 1, it's going to return the value of 6. So now we add 6 to 6 and then return 12. And then we go back again to the first time that we came through this loop, and now we have 6 plus multiply 6 times 2. Well, now we have an answer of 12 for this. That's still 6. So 6 plus 12 is 18. Now we return an answer of 18. And now we've called multiply 3 times and returned from multiply 3 times, and we end up with an answer of 18. So 6 times 3 is 18. This illustrates what's called a trace of the program, which makes it a little bit easier to understand if we just go through this in some detail. The first call to the program has a value of m equal to 6 and n equal to 3, which is order 3. We end up in this else statement because answer n was not equal to 1. So now the answer is 6, that's m, plus multiply of 6 and 2. So now we call multiply the second time, and here we end up in the same place at this else, because again n is not equal to 1 yet, it's still 2. So the answer is 6 plus multiply of 6 times 1. Okay. Finally, we call this again with 6 times 1, so m is 6 and n is 1, order 1. In that case, we don't go to the else, we just go to the answer, and the answer is 16, which returns a 6. Now that goes back to the second call, which is right here, and now we have 6 plus 6, or 12, so now we're returning 12. And then we go back to the first call, which is right here, and we have 6 plus 12, 6 plus 12, which is 18, and that is the final return. We've called the program 3 times and returned it from it 3 times, and so we end up with the actual answer, which is 18. So we've taken a problem of complexity 3, reduced it to a problem of complexity 1, and gone through this process, which allows us to recursively call the same function over and over again to make the calculations. So just to review the general situation here, this is the simple case, solve it, else redefine the problem using recursion. You follow this same kind of simple formula for each one of the programs that you write. So this example illustrates the same kind of a recursive function for finding factorial. It's called int factorial. Int n is our number that we're going to come in. So we come into here. The simple case is if n equals 0, we know the answer is 1. 0 factorial is 1. Else we redefine, the answer is equal to n times the factorial of n minus 1, and return the answer. Very straightforward then.